Hi guys, today we're going to be looking at natural logarithms. Okay, so let's start by reviewing what we already know from previous studies. Okay, we're going to think about the exponential function. So here we've got y is equal to a to the power of x. And you could recognize this, for example, 8 is equal to 2 to the power of 3. 100 is equal to 10 to the power of 2. And we could also say something like 4 is equal to 16 to the power of a half, right? Remembering that the half is the same thing as the square root. And we also saw, we've got the exponential function, that we can rearrange that to get the logarithmic function. So instead of y equals a to the power of x, we can rewrite that as x is equal to log base a y, right? And actually, based on what we've done in the past couple of weeks, hopefully you can see that these two are inverse functions, right? Because on the left-hand side, right, x is my input and y is my output. But on the right-hand side, y is my input and x is my output, right? So actually, these two, we can now think of them as inverse functions. Now, the point of today's lesson is to think a bit more about exponential functions, but focusing when the base is this particular number here, e. Right? This is called the natural number. Natural number. And what you'll see if you plug it into a calculator, I'll show you how to do that in a second, that's roughly equal to 2.71 something. Okay. Now, from your point of view, actually, you don't really care what the number is. That doesn't really matter so much. You just have to treat this like any other number, right? So if you are able to do logarithms with any other base 10, base 2, base 3, then all of the rules are exactly the same when you're dealing with the number e. Okay? So how can we do this? How can we compute with base e? Well, lucky you, I'm going to allow you to use your calculators for this chapter. Okay, so everyone needs to make sure they get their calculator out. I've got a basic kind of Casio calculator here. And we're going to focus on these buttons here. So most calculators, you'll have them in sort of the middle right. You've got the log and the ln buttons, right? I'm just going to zoom in for that here, right? Now, what we're interested in is we're interested in this button in particular. What you should see is you've got a button that will say ln. We'll get to that in a moment. And just above it, there should be something like e to the power of x, right? E to the power of x. So if you wanted to calculate, let's say we wanted to calculate e to the power of 3, okay? Then what you've got to do is you've got to press Shift and the ln button, right? Because that's going to give you this operator here, right? The e to the x. And then just type in 3. So you get e to the 3, hit your equals button. And for me, that gives me 20.1. Okay, and you can do it for lots of others. So for example, let me do e to the 5.2, right? Just take any number at random. So I'm going to do that again, Shift ln 5.2, hit the equals button, and I get 181.3. Okay, so you should be able to do that. Just practice punching the number into the calculator. I think that is relatively straightforward. Okay, all right, now then, if we know about e, the natural number, so we know how to calculate e to the power of something, then it's a short step from there to rearrange it into the logarithmic form, right? So instead of now log base a, we've got log base e. So x can be equal to log base ey. But conventionally in maths, right, we've got a different form of notation for writing this thing here, log base e. Instead of writing that, mathematicians are lazy. We just call this ln, right? So log base e is the same as ln. So we would just write that x is equal to ln ln y. Right? So if you ever see that, if you ever see this thing here, right, ln, all that it means is log base e. It's a short way of writing it because mathematicians are really lazy. Okay, so let's go back to our calculators. Let's go back to this button here. You can see that that's ln. Call it ln. Let's say we wanted to calculate ln 5. And all we got to do in our calculators is hit the ln button, type in 5 and press equals. You should get 1.61. But for another example, let's say we want to do ln of 14.6. Okay, it's a random example. So ln 14.6, punch that into your calculator, hit ln, hit 14.6, hit equals, and I get 2.68. Okay, and remember, what does this mean? What does ln 5 mean? It's the same thing as saying log base e5, right? And ln 14.6 is the same as log base e 14.6. Okay, so it should be fairly straightforward. Just use those buttons on the calculator to calculate powers of e and to calculate logarithmic values. Okay, so just get a bit of basic practice using your calculators. You can pause the video here and you can try exercise 6.7, do questions 1 and 2. Have a go at that. Okay, well, hopefully you've been able to do that. So now the next thing is we want to be able to solve equations using the natural number e. Right now, in the previous studies, we would have had, instead of say e to the power of x is equal to 50, we might have had, for example, 10 to the power of x or 5 to the power of x, and we have to solve. But if we've got e to the power of x, it's just the same principle, right? What we're going to do is we're going to log both sides. So let's log this side here. So we get log e to the x is equal to log 50. Okay? And you remember from the logarithm rules that that means that this power here, x, can be brought down to the front, right? Because if, in case you've forgotten, log of a to the power of p is equal to p times by log a, right? One of our logarithm rules. So now we can write x times by log e is equal to log 50. And if that's the case, then x is equal to log 50 divided by log e. Now, when we were doing logarithms previously, we were using logs with all different kinds of bases, but typically we were using base 10. But actually, we can use any base, and in this particular case, using base e will be the most sensible. So let's introduce that. So I'm going to say that the logs we're going to use here is going to be base e. So log base e to the x, log base e 50, log base e here, right? So everything is log base e. And why have I done that? Well, because then if you look at this thing here, right? Log base e on the denominator, well, hopefully you can remember that log base e will just equal 1. Right? That was one of the logarithm rules we learned last time. So if log base e is equal to 1, then actually I can just say that x is equal to log base e 50. And we know from our calculator that this thing here, right, log base e, we can write that in a different way. We can write that as ln, ln, right? Because remember, ln just means log base e. So in the end, our answer is ln 50, and we can type that into our calculator. Ln 50 equals 3.91. Okay, so just to recap, what are we doing? If we want to solve an equation like this one here, right, that one there. Well, before what we know is that we have to log both sides. But what I'm telling you is, if you're dealing with a situation where you've got the natural number there, e, then the logarithm you choose is log base e, the natural log. Okay, let's try another example. Okay, here we've got e to the power of 3x is equal to 15. So how do we do that? Well, we're going to natural log both sides. So we're going to do ln of e to the power of 3x is equal to ln 15. And bring that power of 3x down to the front. Right? Because remember, ln is just the same as all the other logarithms that we've done. The rules still apply. So we get 3x ln e is equal to ln 15. And now you should remember as well that ln e will equal 1 because it's log base e, right? So ln e is equal to 1. And so we end up with x is equal to ln 15 divided by 3. Okay, and I can do that in my calculator. Ln 15, close bracket, divided by 3. And I get 0.90. Okay. Do another one. Here we've got a half e to the power of 2x plus 1 is equal to 15. Well, before I can solve that, I need to deal with that half there. The easiest thing to do is just multiply both sides by 2. So if I do that, I'm going to get e to the power of 2x plus 1 is equal to 30. And now I can natural log both sides. So the natural log of e to the power of 2x plus 1 is equal to the natural log of 30. I can bring that power of 2x plus 1 down to the front. I end up with 2x plus 1 times by the natural log of e. Remember that the 2x plus 1 there must be in brackets, right? Because it's the whole thing multiplied by ln e is equal to ln 30. You remember that ln e is equal to 1 because it's just log base e. So 2x plus 1 is equal to ln 30, which means that 2x is equal to ln 30 minus 1. And therefore, the x is equal to ln 30 minus 1 divided by 2. And so you can put that into your calculator. Ln 30, hit the equals button. Subtract 1, hit the equals button. Divide by 2. What you should get, sorry to go to the side, is 1.20. Okay. All right, guys. I think that's enough for you to be getting on with. I think that you can try to do exercise 6.7, questions 5 and 6, please. Okay. We'll return again with another video. Bye.